March 10, 1905, Brockton, Massachusetts. At exactly 7:30 in the morning, a machine that had been running quietly for years turned into a weapon powerful enough to tear a building apart from the inside. Not slowly, not with warning, instantly. 15 tons of iron didn't just fail, it launched. It ripped through 3 floors of a factory filled with workers, tore through the roof like paper, crossed a public street while still airborne, and landed inside a home 300 feet away. 58 people were dead in under 5 seconds. Some never heard the explosion. Some saw it coming and couldn't move. And what makes this worse is that everything about it had already been predicted. They knew this could happen. They built it anyway. The R.B. Grover shoe factory didn't feel dangerous that morning. It felt normal, predictable, the kind of place where routine settles into your bones so deeply you stop questioning anything around you. Rows of sewing machines rattled in rhythm, their metal needles punching through thick leather with mechanical precision. The air smelled like oil, dust, and heat, the kind of industrial heat that never really leaves your skin. Women leaned forward over their stations, stitching uppers together piece by piece, hands moving fast because speed meant wages. Men moved between work areas, hauling stacks of material, boots scraping against worn wooden floors, polished smooth by years of traffic. No one was thinking about risk. No one was thinking about failure. Because the most dangerous thing in that building didn't look dangerous at all. It was in the basement. Out of sight, out of mind. A steel cylinder the size of a railroad tank car, sitting in a brick chamber like it had always been there. The boiler. It didn't shake, it didn't roar, it didn't give off any signal that something inside it was waiting to break. It just hummed, low, steady, controlled. Fire burned inside its tubes at over 2,000 degrees, heating thousands of gallons of water under pressure so intense it defied basic instinct. Water that should have been boiling violently at 212 degrees was being forced to stay liquid far beyond that point. At 150 pounds per square inch, it stayed stable past 350 degrees. At higher pressures, it climbed even further, quietly, invisibly. That's the trick. It looked calm, but it wasn't calm. It was contained chaos. 20 minutes before the explosion, a fireman walked past it and saw nothing wrong. That detail matters because it tells you everything about how these machines killed people. There was no dramatic buildup, no shaking walls, no warning whistle screaming danger. The gauges read normal, the water level was fine, the pressure sat exactly where it should be. He moved on, did his job, probably didn't think about it again. And why would he? The boiler had been running like this for years, day after day, shift after shift. The same sounds, the same heat, the same routine. Familiarity had turned something lethal into something invisible. But inside that boiler, something had been building for years. Not pressure, the pressure was controlled. Something worse, fatigue. Every morning the metal expanded as it heated. Every night it contracted as it cooled. That movement was microscopic, almost impossible to detect, but it happened thousands of times over the life of the machine. And metal doesn't handle that kind of repetition well, not forever. Tiny cracks begin to form deep within the structure, not on the surface where you can see them, inside, along stress points, around rivet holes, at the seams where plates overlap. Each cycle makes them grow a little more, not enough to notice, not enough to alarm anyone, but enough to matter. And then there's corrosion, because the water inside these boilers wasn't clean. It carried minerals, oxygen, chemical impurities that slowly attacked the iron from the inside out. Over time, scale built up along the interior walls, a hard, crusty layer that trapped heat in uneven ways. Some areas ran hotter than others. That uneven heating created stress. More stress meant more cracking. And beneath that scale, the iron was thinning, weakening, being eaten away in places no one could inspect. From the outside, the boiler looked solid, reliable, safe,
But internally, it was already compromised, already failing, already moving toward a point where it couldn't hold itself together anymore.
And here's where the real problem begins. Because even if someone had suspected something was wrong, they wouldn't have been able to prove it. The technology didn't exist. No X-rays, no ultrasound, no internal imaging. Inspections were primitive. Tap the metal with a hammer and listen. That was it. A dull sound might mean corrosion, or it might mean nothing. It wasn't science. It was guesswork, and guesswork doesn't stop explosions. So the machine kept running, day after day, quietly accumulating damage that no one could see.
At some point that morning, a single rivet failed. Not dramatically, not with a loud snap that echoed through the building, just a small piece of iron giving up after years of stress it was never truly designed to handle. That rivet was one of thousands holding the boiler together, each one a potential weak point, each one a tiny flaw in a system that depended on perfection. And perfection doesn't exist in real-world engineering. When that rivet failed, it created a microscopic opening, barely noticeable, but the moment it opened, everything changed. Because inside that boiler, the water wasn't just hot, it was superheated, held in liquid form only because of the pressure surrounding it. The instant that pressure dropped, even slightly, the water didn't just start boiling, it flashed into steam, instantly, violently. 1 gallon expanding into over 1,000 gallons in a fraction of a second. That expansion doesn't ask for space, it takes it. The opening created by that single failed rivet became a trigger, a chain reaction. Pressure dropped locally, water flashed into steam. That created more pressure, more stress, more failure. And then the entire structure gave way. It doesn't unfold in stages. There's no gradual escalation anyone inside the building can react to. The failure cascades faster than the human brain can process what's happening. The initial rupture widens in an instant, the iron shell tearing along its weakest points, rivet lines, seams, places that have been quietly deteriorating for years. The pressure inside doesn't escape, it detonates outward. The water flashes into steam all at once, expanding with such force that the boiler itself becomes a projectile before it even fully comes apart. The basement disappears first, not collapses, disappears. The space where the machine sat is violently erased, replaced by a shock wave that slams upward through the structure. The first floor doesn't stand a chance. Wooden beams snap like dry sticks under sudden upward force. Floorboards explode into splinters. Sewing machines, hundreds of pounds of cast iron, are ripped from their positions and hurled across the room like toys. Leather, tools, bodies, debris, all of it becomes airborne in the same violent moment. And then the boiler itself comes through, not as a single intact cylinder, but as a mass of tearing metal and momentum. 15 tons doesn't move gracefully. It punches upward, smashing through the second floor with unstoppable force, carrying fragments of the building with it. Walls rupture outward. Windows don't shatter, they vanish, pulverized into dust by the pressure wave. People in adjacent rooms don't see what's happening. They feel it. A wall slams into them. A beam strikes. The air itself turns solid for a fraction of a second and crushes their lungs. By the time the boiler reaches the roof, it's already shedding pieces. Plates tear free along riveted seams. Bolts shear clean off. Each fragment becomes its own weapon, spinning, accelerating, cutting through anything in its path. The roof offers no resistance. It's obliterated. The boiler exits the building in a violent arc, still carrying energy, still moving with enough force to travel across the street like it was thrown by something larger than the building itself. Outside, the world hasn't caught up yet. People are walking, talking, living ordinary moments, and then the sky above them fills with debris, not falling gently, arriving fast, sharp, deadly.
The boiler crosses that distance in seconds and crashes into a house, tearing through the structure and embedding itself where a living room had been moments before. Walls collapse inward, furniture shatters into splinters. Anyone inside has no chance to react. The violence doesn't stop at the factory boundary. It spills outward, indiscriminate. Back at the factory, what's left of the building begins to fall inward, not because it was designed to collapse that way, but because the core support, the space where the boiler sat, has been obliterated. The floors above lose their foundation. Gravity takes over. Timber, brick, iron, and bodies drop into the void in a chaotic collapse that lasts only seconds, but feels endless to anyone trapped inside it. Dust fills the air instantly, thick enough to choke on. Visibility drops to nothing. Sound becomes muffled, distorted, drowned in the roar of debris still settling.
And then, silence. Not complete silence, not peaceful, the kind of silence that follows something violent. Broken only by small sounds, the crackle of fire starting somewhere in the wreckage, the hiss of escaping steam, the shifting of debris as the structure settles into its new, ruined shape. For a moment, the city doesn't understand what it's hearing or what it's not hearing, because an entire factory just went quiet in the span of a few seconds. The first people to react aren't inside, they're outside, witnesses who saw the roof vanish, who heard something that didn't sound like any normal explosion. Survivors will later describe it as the earth tearing itself open, not a sharp blast, but a deep, ripping sound that seemed to come from everywhere at once. People run toward the building, not away from it, because instinct tells them something catastrophic has happened, but not what. When they arrive, the factory is no longer a factory. It's a pile, a collapsed mass of brick, timber, twisted iron, and dust. The structure has folded into itself, burying everything that was inside it. There are no clear entry points, no obvious survivors, just destruction. And then the sounds begin to emerge from within it. Voices, faint at first, then louder, screams, calls for help, some trapped under beams, some pinned beneath machinery, some unable to move at all, and some already beyond help, but not yet silent. Rescue doesn't start as an organized effort. It starts as chaos. People pulling at debris with bare hands, lifting whatever they can, ignoring the risk that the rest of the structure could shift and collapse again at any moment, because there's no time to think about safety. The injured are buried alive. Every second matters. But every second also makes it worse. Fires begin to spread from scattered coal and ruptured fuel sources. Smoke mixes with dust, making it harder to breathe, harder to see. The same steam that powered the factory now escapes in uncontrolled bursts, hissing through cracks, burning anyone who gets too close. And then there are the bodies. Some found immediately, some partially buried, some so badly damaged they're unrecognizable. The violence of a boiler explosion doesn't leave clean scenes behind. It leaves fragments. It leaves confusion. Families begin to gather outside the wreckage, searching for faces, for names, for any sign that someone they know might still be alive inside that pile. Hospitals fill almost instantly. The injured who can be pulled from the wreckage are rushed out, carried, dragged, supported by anyone available. Burns, crush injuries, internal damage that isn't visible but is already fatal. Doctors don't have enough beds, they don't have enough supplies, they don't have enough time. Hallways become treatment areas, floors become operating spaces. Decisions are made quickly, who can be saved, who can't. And while all of this is happening, one question begins to form, quietly at first, then louder. What caused this?
Because explosions like this don't just happen without reason. Not in a building that was functioning minutes earlier, not in a machine that had been running for years.
There has to be an explanation. Investigators will arrive, they always do. They'll sift through debris, measure distances, collect fragments of the boiler scattered across the area. They'll reconstruct what happened as best they can. But here's the problem. They're looking for a moment of failure, a single cause, a mistake, something simple enough to explain and close the case. But this wasn't a single failure. It was a system failure, a design failure, a cultural failure. Years of accumulated risk built into one machine that everyone depended on, but no one truly understood. And that's harder to investigate, harder to admit, harder to fix. Because if the cause is systemic, then the problem isn't just this factory. It's every factory, every boiler, every building using the same technology. And by 1905, that meant almost everything. That's the part no one wants to say out loud, because admitting that means admitting the entire industrial system is built on something unstable, something dangerous, something that could fail again, anywhere, at any time. And it already had, for decades, in different cities, different industries, different buildings, the same pattern repeating itself. Small warning signs ignored, larger failures dismissed, catastrophic explosions treated as isolated incidents instead of symptoms of a larger problem. But now, in Brockton, the scale of destruction is impossible to ignore. The machine didn't just kill workers, it crossed boundaries. It killed people outside the factory. It reached into spaces that were never supposed to be at risk, and that changes how people see it. What happened in Brockton didn't exist in isolation. It only felt that way because it was immediate, visible, impossible to ignore. But across the country, the same machines were sitting in basements, behind walls, under floors, quietly doing the exact same thing, storing the exact same kind of energy, waiting under the exact same conditions. And some of them had already failed. Not once, not twice, dozens of times, in different cities, under different circumstances, but always with the same ending: sudden violence, total destruction, and investigators standing in the wreckage trying to explain something that was already understood but never fully acknowledged. Kansas City, 1888, a packing plant running at full load when the crown sheet fails. That's the most critical part of the boiler, the surface directly exposed to the fire. If water drops too low, even briefly, that metal overheats beyond its limit. It weakens, warps, and then it gives way. In Kansas City, it didn't just fail, it collapsed inward. Thousands of gallons of water dumped directly onto an open furnace, burning at extreme temperature. The result wasn't just an explosion, it was an instant conversion of water into expanding steam, a violent reaction that turned the entire boiler into a bomb. 12 men were killed, 30 more injured. The boiler itself didn't stay in the building, it tore through it, launched into the air, and landed blocks away, still hot enough to ignite what it hit. Wisconsin, 1990, a paper mill operating like any other. No warning, no visible issue, but inside the boiler, a crack had been forming along a seam where a tube met the end plate. It started at a rivet hole, because that's where stress concentrates. It spread slowly, invisibly, until the metal could no longer hold. When it finally split, it didn't leak. It didn't give anyone time to react. The tube ruptured completely, releasing pressure instantly. The boiler didn't explode outward. It went vertical, shot straight up through the building, punching through the roof like it was designed to escape. It traveled over 100 yards before crashing into a river. 17 people were dead before anyone understood what direction the danger had come from. Rhode Island, 1895, a textile mill similar to Brockton, same layout, same dependence on steam, same assumptions about safety.
This time, the failure happened along a longitudinal seam, the weakest line running the length of the boiler. Rivets that had been holding for years began to fail in rapid succession, not one at a time, together. The seam opened like a zipper being pulled apart at full speed. The entire shell split open, the pressure released instantly across the full length of the structure. The explosion didn't just destroy the boiler, it disintegrated it. Pieces scattered across a quarter mile. 23 people were killed. The largest fragment found weighed hundreds of pounds and was embedded in the ground hundreds of feet away. 3 different locations, 3 different failure modes: crown sheet collapse, tube rupture, seam separation. But the outcome was always the same: sudden release of energy, total loss of containment, lives erased in seconds. And yet, the pattern never fully connected in the minds of those responsible for preventing it, because every time it happened, the explanation stayed small, local, contained: a bad operator, a maintenance failure, a defect in one machine, something specific that could be blamed, documented, and moved past. That's how systems protect themselves from the truth, by shrinking it into something manageable, something that doesn't require everything to change. But the truth was bigger. The truth was structural. These machines were not failing randomly, they were failing predictably. The combination of material limitations, design flaws, and economic pressure created a system where failure wasn't a possibility, it was a certainty over time. Every boiler was on a clock. The only variable was when it would reach zero. And still, they kept building them, because the alternative didn't exist yet, or at least not at the scale required to replace what steam had created.
Never designed to absorb that kind of force. In Brockton, 14 of the dead weren't even factory workers. They weren't part of the system. They weren't exposed by choice. They were simply nearby. And that changes the equation completely, because now the risk isn't contained, it's public. And once a risk becomes public, it becomes political. Pressure starts building, not inside boilers this time, but outside them, in newspapers, in town halls, in conversations that didn't exist before. People begin asking questions they hadn't asked before, not just how it happened, but why it was allowed to happen. And for the first time, the answers aren't enough. The shift doesn't happen overnight. It never does. Systems like this don't collapse because of a single disaster. They resist change, absorb it, explain it away, rebuild, and keep going. But something after Brockton feels different. Not because it was the deadliest, not because it was the first, but because it exposed something no one could comfortably ignore anymore. The danger wasn't contained. It wasn't controlled. It wasn't even predictable in the way people had convinced themselves it was. It was everywhere, and it was waiting. Newspapers begin to frame the story differently, not as an accident, not as a tragic mistake, but as a consequence. That word matters, because consequences imply cause, and cause implies responsibility. Headlines don't just report the number of dead, they question the machine itself. They question why something capable of that level of destruction is allowed to sit beneath workplaces, beneath homes, beneath entire city blocks. And for the first time, the public starts to understand what a boiler actually is. Not a heating device, not a background system, but a pressure vessel storing enormous amounts of energy in a confined space. A machine that operates safely, right up until the moment it doesn't. And when it doesn't fail gently, it fails violently. Engineers had known pieces of this for years. They understood pressure, they understood heat, they understood, at least in theory, that the forces involved were dangerous. But what they didn't fully understand or didn't fully accept was how those forces behaved over time, how materials degrade, how fatigue accumulates, how small imperfections evolve into catastrophic failure points. Because the math said it should work, the calculations showed safety margins, the designs met the standards of the time. On paper, The system was sound. But reality isn't paper. Reality includes imperfections, variations, conditions that don't match assumptions. And when you're dealing with stored energy at that scale, small deviations don't stay small, they compound, and eventually they break everything. So the pressure to act grows, not just from the public, but from insurance companies, because they're the ones paying for the damage. Every explosion means payouts.